Hey folks, we're going to talk about the last theorem in our book 8, and that is theorem 90. It's the side-side-side similarity theorem. We did have side-side-side to prove that two triangles are congruent, but this is similarity. And what it says is that if the corresponding sides of two triangles are proportional, then the triangles are similar. So we set up already, and this is what it's telling us. Our part of our definition is AB is corresponding to DE. So AB is corresponding to DE. AC is corresponding to DF. And BC is corresponding to EF. So if we have these, and we're saying, therefore, that if we find that these are true, then AB is similar to DE, AC is similar to DF, and BC is similar to EF. Therefore, triangle ABC is similar to triangle DEF. So these two triangles are similar because we proved that the corresponding sides are proportional, and they're all the same proportion. So let's take a look at this, and for a real example, we're going to see that we have two triangles here. All right. Now, in this case, if you look at it very closely, a 6 and a 12, 7 and 14, 8 and 16, hopefully you can see that there is a sense of something that you recognize there. But if we say that we use the same thing as we have up top there, and we said that AB is corresponding to DE, and AC is corresponding to DF, and BC is corresponding to EF, then we can set this up into a very nice little proportion. So we can say 6 over 12 equals 7 over 14, and then 8 over 16. Very simple. Now we see that we have something that looks alike here. 6 is half of 12. 7 is half of 14. 8 is, we can reduce all these to 1/2. So now we see that each one is proportional. We can say that triangle ABC is similar to triangle DEF. Okay? Now, this is pretty straightforward. We got the corresponding sides together. So what happens? We always have to check. What happens if they're not so easily corresponding? So we have two triangles here. We have this triangle. It's a smaller triangle, 4, 5, and 3, 12 and a half, 10, and 7 and a half. Well, let's just see, we have to work it. Is this side corresponding to that side? Question mark. We don't know. So let's try it out. Let's just say it is 4 over 12.5. And let's say 5 over 10. All right. So we're going to go ahead and say this is 40 equals 66. No, let's see. 12.5 times, sorry, Noah, I'm a little slow here. 5 equals, all right, 62.5. Since they don't equal each other, that means that this side is not corresponding to that side, and this side is not corresponding to this side. So we got a little bit of a problem there, right? So what do? Well, maybe we could take this triangle and flip it over and see what happens. So let's see if 4 corresponds with 10. So we'll say 4 over 10. That means if we flipped it over, 5 corresponds with 12.5. So what do we have here? We have 4 times 12.5 All right, so we're going to cross multiply. We find out that this is 50 equals 50. So that's perfect. It matches. All right, so that's good. So let's just make sure that these guys here are corresponding. We already figured out we could take either one of these, it doesn't matter, and find out if they correspond with these guys. So 4 and a 10 is easier to multiply. So let's say 4 over 10. We know that those guys are corresponding, these sides. So let's say equals 3 over 7.5. All right, so we have 30, and 4 times 7.5, and that is 30. So now we see we have these. So the moral of this story is, if it doesn't work out, if you don't see that proportional, then do another side. If you don't have a hint saying that, for example, this angle is the same as this angle, then we have the two sides here, and that's the side angle side theorem. So we have what we needed there, 5 over 12 and a half, we have it. So be sure when you're getting problems, if it doesn't work out, that you change around and you try another one. Just don't stop after the first time. Keep trying. Remember, you can email me anytime you want at sunshinichols.yahoo.com or on the Google Classroom, and let me know how you're doing. All right? Take care.